Welcome to the afternoon session. This is the CyberGIS Showcase. So Showcase is a term that got worked around in terms of what it was the CyberGIS NSF project was attempting to show as a best foot forward kind of a thing. And Showcase are coming about because of an evaluation that took place among the executive committee, thinking that these were three of the best things that we have to show at this point in time. So without much ado here, I'm going to introduce Kalev, Leetaru, Eric Shook, and I know those two are going to speak, but Xiaowen Wang, as you all know, as you can see on the screen here, is also one of the authors. So a CyberGIS approach to digital humanities and social sciences, the world of textual geography, and a case study of Wikipedia's history of the world. So.
Thank you. So I've got a 2-hour talk to give to you in 15 minutes, so strap down and hold on. So I want to tell you a story that begins 4.5 billion years ago with the creation of a planet called Earth. A few billion years went by, until about 50,000 years ago, the first modern humans began walking around. Something very interesting started happening about 38,000 years ago. They started leaving a permanent record, cave paintings. Then about 8,000 years ago, the first writing begins. 550 years ago, the printing press shows up, and people begin printing incredible amounts of material. And then 20 years ago, the first graphical web browser shows up on the scene, and society just goes crazy, collectively creating this incredible record of human society. Fast forward to today, and we've reached an incredible point in human history. Nearly everything we do today is digital. 644 million websites, 150,000 new ones added every single day, upwards of 156 million blogs, 300 billion emails, 17 billion SMS messages every single day. And it's growing faster and faster and faster. The entire New York Times over the last 60 years had just 3 billion words. Today, every single day, there are over 8 billion words posted to Twitter. That's right. Every single day, there are 2.5 times as many words posted to Twitter as in every article of every issue of the paper of record of the United States of America over the last half century. By some estimates, there were 50 trillion words in all the books published over the last half millennia. In just 3 years from now, Twitter will hit that mark. You think about just how much data that really is. There are 2.5 quintillion bytes of new data created every single day. Every week, the equivalent of all the words ever spoken by human society since the dawn of the species transits the global internet. Now pause for a moment to take all this in. Nearly a third of the planet's population is connected by a single network, a single massive network that brings everything together. There are as many cell phones as there are people on Earth. Today, people from Bangladesh to Buenos Aires busily tell one another and their neighbors what they see, what they think, what's important to them, offering unparalleled visibility into the global life. Moreover, the constant stream of background information that flows across these networks gives us unparalleled, rich contextual background image on the narratives of each culture and region. Location itself is becoming a form of publication. Services like Foursquare and Facebook are encouraging users to constantly broadcast their locations. If ever we were at a point in human history where we could take all this information and use it to measure the heartbeat of global society, we are there. Citizens are becoming a vast ground-based social sensor network, providing a continuous real-time stream from almost every corner of the world. While the news media is able to contextualize those thoughts into rich narratives that transcend traditional journalistic boundaries. A common denominator of all this is that so much of this communication is mediated by text, whether that's the written word or a transcript of my speech here today. Language brings us together as a society. It's how we express ourselves. It's how we express our emotions. Language is rich in location. Every piece of information is created in location, intended for an audience in a location, and potentially describes yet other locations. Location is the principal organizing structure around which all other information is created. Over a quarter of web searches globally involve location. The traditional approach to visualizing all of this information has been to map metadata. Some information has location metadata built in. So Twitter, for example, geotagged tweets. But that's less than 1% of all tweets. Other locations, for example, Wikipedia has hand annotated location information. But again, that's just a fraction of the spatial information in this material. The real spatial information that we care about is in the content itself. And that's very, very difficult to access. We don't have mechanisms historically. We haven't even attempted historically to delve within that. We've looked just at the surface. And to give you an idea of just how rich text is in location, encyclopedias have a location every 44 words. The global news media, that's print, broadcast, radio, television, in every language across Earth from every country of Earth, average about one location every 200 words. So you think about just how much spatial information there is. Well, how do we extract that? How do we extract that space from that pile of text and make that into a spatial context? Well, we start with gazetteers, databases of recorded locations around Earth, primarily GNS and GNIS, which are two large gazetteers that form the basis of most global gazetteers. We begin by taking a document, we parse through it, we find every name, so that could be a person name, it could be a location. We check those against these databases. We try to find, well, is there a possible location with this name anywhere on Earth? Then we go through that and we say Cairo. Well, there's 41 Cairos on Earth. Which of these 41 Cairos is this mentioned probably referring to? So we're using a lot of rich contextual information. The problem with disambiguation is it's a really difficult problem. If you look across the world, and what you're seeing here, the colors, the darker the color is the higher percentage of locations in that country that have other locations with the same name within that country. So for example, a reference to Urbana, USA, well, there's 11 cities named Urbana here in the United States. And actually, there actually was an article I saw coming out of Egypt about a year or two ago discussing the U of I, but all it actually referenced was a university in Urbana, United States. Because to them, that's all that mattered. But if I'm trying to geocode that, if I'm trying to actually convert that to mappable coordinates, that matters. Globally, 1 in 3 locations on Earth have another location with the same name somewhere else. On a country-by-country basis, that varies from 0% to almost 50%. But there are a variety of approaches to this. By and large, the literature that's evolving so far has achieved up to 76% accuracy at this task, and that's down to the smallest village in the corner of Earth, and at great, great speeds. Now, why would we want to do this? Why do we care about space? Why do we care about extracting space from text? Well, we could take all the locations mentioned in all the coverage of bin Laden over the last 30 years up until the month before he was captured, and we can make a map of that. And we can have all roads lead to a 200-kilometer radius around the city he was ultimately captured in. But what we really care about is we want to integrate tone. That's the real interesting part, is reading between the lines, looking at the latent dimensions of text. Well, we can calculate tone. And there's a variety of ways we can do this. There's over 1,800 different tonal dictionaries that exist today. Everything from positive, negative, optimism, fear, confusion, anxiety, you name it, and there's a dictionary to measure it today. And you might say, well, how does that work? Well, traditionally, the way this often works is there's a dictionary that someone created of positive words, negative words. You think about it, a document says wonderful, terrific, fantastic, amazing, and another one says horrible, awful, horrific. Well, probably most people seeing that would say, this one's more positive, this one's more negative. Again, they're approximations, but they work at scale. And oftentimes people say, well, it can't take into effect sarcasm or humor. But actually humans can't. We actually had a series of political science graduate students, and we gave them editorials from the 1940s from presidential elections. And actually we had them score them positive and negative, and they were getting huge numbers of them wrong because, for example, an article would say, so-and-so is an amazing orator. He captivated the audience with his amazing speech. Well, to someone today that doesn't know the background, well, that's a real positive discussion. In reality, that was a lampoon because that candidate was known for very poor speaking skills. So really, oftentimes when we say, well, machines, they can't do as well as humans. Well, humans don't do all that well to begin with. And again, these are approximations. The idea is, how can we visualize that? And if we take space and we combine that with latent dimensions, we can do things like this, visualizing global conflict and cooperation across the world. And that led to a question. Traditionally, we plot all this through time. We traditionally take tone and we plot it just in a timeline. But what becomes very interesting is placing it in space. And this led us to a question. Wikipedia is perhaps the most studied collection on Earth right now, at least in the computational world. Yet after a decade, we still know very little about what Wikipedia really tells us about the world. What is its view of history? In a collaboration with SGI, over 80 full-text geocoding, full-text date coding, and sentiment mining was applied to the entire 4 million document English language version of Wikipedia. Over 80 million locations and 40 million dates were extracted from that. Every article was tone-coded and combined together. So essentially we had a reference to in London in 1873 became a data point. London, 1873, and the tone of that over time. Now I want to stop for a moment and say, if we didn't have space, what could we do with this? Well, this is the view of Wikipedia in time. The top graph is a log scale of the total number of mentions of each of those years across all of Wikipedia. And if you look at this carefully, you can see actually 4 major periods in global history according to this. The bottom scale gives us tone from positive to negative and shows us many of the key areas in world history. Conflict and cooperation, pessimism to optimism in Wikipedia's Chronicle of the World. The problem is that without space, this is where it ends. This is all we can do. This is all we can say about the world history. And really, we want to go beyond this, obviously. Space is so important to us. So the world becomes a very different place when we integrate space. This is what we do. This is what happens when we integrate all that full-text geocoding here. Essentially, we're taking tone and we're layering onto a geographic strata. The problem, though, is that full-text geocoding gives us centroids. A reference to Beijing becomes a single latitude-longitude, just like Urbana here. We don't have the ability to represent how large cities are, how important they are. Now, again, there's many ways we can do this. There's many symbologies, such as sizing dots and so on. The problem is, already you can see this is a pretty cluttered map. There's a lot of points here. If I start sizing these dots based on a number of mentions, pretty quickly it's going to become very difficult to read. And already we can see Europe and the US, by and large, are just colored blobs. There's so many points that it's almost impossible to actually see it. And that's actually a real problem. When you go to full-text geocoding, the number of points you can extract from this, 80 million from Wikipedia, over 1 billion from another project, it just becomes almost unmanageable. So how do we visualize this? Well, we can try doing some things. We can sort by intensity. We can do different sorting techniques here. We can do alpha blending, so we can make each point semi-transparent and see if that helps. And that helps a little bit. But I want you to take a real close look at the West Bank here. Now, probably most of you, when you first look at this map, very few of you probably jump right to the West Bank and said, wow, look at that, look at what's happening there. And the problem is because in areas like West Bank, or actually in Syria today, there's so much activity there across so many different locations. But it's centralized in such a tiny spot that you don't notice it. It just sort of disappears in the backdrop of that map. So, and also this is just telling us tone. This is telling us one single thing, the tone. There's no notion of the importance of that city, of the total intensity of discussion there. What we really need is a map that can combine multiple levels together. Now take a look at this. This is everything Wikipedia tells us about armed conflict with respect to the year 2003. So to generate that, we took those 80 million locations and then went back to that and said, well, what are the locations that are discussing 2003? And then what are those that appear next to keywords that were derived from the armed conflict page on Wikipedia? So when we map this, probably most of you immediately jump to the lower right here, down to the West Bank. It just popped right out at you. Well, that's one of the benefits of being able to move to a technique like this. It's not just a pretty picture. It's actually an enormously complex spatial representation of media effects. What you're seeing here is actually taking into account the total popularity of that location, the percentage of the discourse around that location with respect to that topic, and the overall tone. Now imagine instead of this map, you're seeing a map of spatial discussion of, say, a terror group. You have an emerging terror group. You want to know, what are people saying about this? Where is that coming from? How are people relating to it? And you could use that and look at spatial trajectories and compare that to other groups and similar spatial movements. The massive scale presents very unique challenges to understanding and visualizing it, but also enormous opportunities in being able to take a fundamentally new approach to exploring the complexity and dynamics of human society using data-driven knowledge discovery. Now keep in mind, this entire process started with just a pile of unstructured text and an idea. We use full-text geocoding to extract every location, date coding, sentiment mining, across 4 million articles, and fed all that in, and we get this map. This entire pipeline of all these algorithms and processes lives in the cloud and all runs on HPC hardware, courtesy of GISolve, available at a moment's notice from an API call. Now, the full-text geocoder actually that was used for this has been benchmarked at 500K of text per second per core. If you do the math, you could effectively handle the entirety of the Twitter Firehose feed on a single core. And that's assuming the complexity of Wikipedia articles, where there's enormous amounts of disambiguation across that article. Now, I want to say something that's also very unique about our collaboration here, and that we're bringing a very strong communications and informatics science perspective to how we capture latent dimensions. There's been a growing trend to just sort of take media, especially social media, and just sort of plop it onto a map without understanding really how media functions. I mean, media is very different across geographies and across cultures, and the impacts of that on the analytic process. And so a big focus of what we've been doing is trying to understand, how do we do that? How do we, as accurately as possible, try to use media and latent media dimensions to proxy global society. Now with that, I'm going to pass the mic to Eric to basically pull back the curtain on all of this and show you how all this magic happens.
Thank you. Hard to follow, but I'll try. So essentially the workflow that Kalev is seeing right now is he takes a huge amount of text, something like Wikipedia. He pushes it through his full text geocoding module, passes it through sentiment mining, sends it to this black box called CyberGIS, called GISolve, and out pops this kind of cool looking heat map, right? So my job in this presentation is mostly to kind of peer inside the CyberGIS black box. So some of these diagrams you've seen. So in day one, we actually did a hands-on demo for those of you who weren't around, and actually was able to play with this demo, looked at the 2003 Wikipedia data, made a heat map through the open service API. So as Kalev mentioned, we have this open service API, and this open service API is just a set of functions that he can programmatically access all of GISolve middleware. Now this GISolve middleware is obviously kind of a computationally complex system. And all of that is hidden through the open service API calls. And then, of course, we sit on top of cyber infrastructure. But what I really want to focus is that emotional heat map method in the bottom, because we've been talking about these kind of 3 layers the past couple of days. So I'm going to walk you through what we see, and I hope that this is the most technical slide that I have in the presentation. I realize everybody's coming back from lunch and is probably pretty tired. So the actual data input that we see for this method from the sentiment mining and full text geocoding is we get a set of latitude, longitude, point locations and 3 attributes. The first attribute is the number of articles mentioning this location. So each time London is mentioned, let's say, this count goes up by 1. The second attribute is the number of articles mentioning both this location and a topic. So the topic could be armed conflict. So if you have an article mentioning armed conflict and London, this count goes up. And then we also have average tone of articles mentioning the location and the topic. So that article that was mentioning both armed conflict in London, was it generally negative or was it generally positive? Now, a lot of methods would generally take the second attribute, so the number of articles mentioning both this location and topic, shove it into something like kernel density estimation and make a heat map. Well, that might not necessarily be the full picture. And how do you incorporate this tone? This is certainly interesting. So this is really what this method is trying to do. So the overall, after speaking with Kalev and working through this problem, we identified 3 important elements. One, of course, and the most important, is the importance of location. So location really matters in this. The second is the prevalence of topic at that particular location. Now this is nested, right? Because we have location and space is important everywhere. So what's the prevalence of the topic at that location? Does it matter? Does it not matter? And then, of course, you have the emotion toward the topic. What's the tone? So we're trying to capture all these 3 elements in a single map, and this is what this method is trying to do. So we're going to start with the first element, the importance of location. So every mention of a location increases its importance, and that's one of the assumptions in our method. So every time London is mentioned in an article, our method is assuming that it is more important for this text. And we do this by generating a density map of the number of times a location is mentioned in text using a very popular method used for heat maps called kernel density estimation. We're using a k-nearest neighbor search, very popularly used because this data is very heterogeneous, excuse me. So you might have areas that are very dense and areas that are very sparse. So with this k-nearest neighbor search, it allows us to kind of adapt to that kind of data. And if you look at the Wikipedia data, this is a article density map of Wikipedia with respect to the year 2003. So you can see that, you know, the east coast of the United States and certain parts of Europe have a very high article density count. They're mentioned a lot in Wikipedia for the year 2003. Now, of course, that isn't the entire picture. We also have to look at the prevalence of the topic at that particular location. So we term topic intensity to capture the prevalence of a topic relative to all of the other topics. And we adopt a method commonly used in epidemiological studies to estimate it. So for those of you who have heard of relative risk, it's the ratio of the kernel density estimation of disease infection locations, the point-based locations where disease is, and your case control locations where your susceptible population is. So if we do this kind of analogous comparison to relative risk on the bottom, you have the density of the points with disease on the top, density of the points without disease on the bottom. If we look at topic intensity, we can take the density of the articles that mention a topic on the top and the density of articles that aren't mentioning the topic on the bottom, and we get kind of this topic intensity. This is going to be the prevalence of the topic being discussed in this text. And if we map that out, you can see that in certain areas the topic is very intense across the world, and in certain parts of the world this topic isn't very intense. And again, this is Wikipedia data, 2003 armed conflict. This is the hands-on demo data that we were playing with earlier. Bright purple indicates areas of great topic intensity. The third element is probably the most challenging for us. So the question became, and this kind of went around the group, and we were speaking with Kalev, is the emotional measure tone discrete or continuous? So we had arguments for both, and we kind of worked through it. So the question becomes, is tone countable like trees, or does it exist like a continuum like air temperature? And eventually we decided that tone is a continuum because you can't really have a number of tones. So there we had to actually change our method, and instead of using KDE, we switched to inverse distance weighted interpolation in order to estimate the tone. So our tone map is going to capture both our positive and our negative tones across space. And if we map that out for Wikipedia for armed conflict, you can see that North America seems to be pretty positive about armed conflict. The Middle East and Africa, maybe not so much. Now, if you take these three elements, we have our article density, which is our proxy for the importance of location. We have our topic intensity, the prevalence of topic relative to other topics at that particular location, and tone, which is our proxy for our emotion toward a topic. If we look at these first two layers, they're really kind of scaling factors for tone. So this makes sense. So if you have a very negative tone, but the topic itself doesn't necessarily matter in that particular location, it really doesn't affect the population. Or you might have a very negative tone, and the topic might be very intense, but you just don't have enough people. The location itself just isn't important enough. So if you combine these three factors, using raster multiplication, article density, topic intensity, and tone, we generate this emotional heat map. Now, I realize that some of the hardcore spatial analyst people might be cringing a little bit because we're really adapting these methods. But as we were talking with some of the spatial and social media people, there really just aren't methods designed to handle this kind of data. So this is what we're doing. We're kind of taking the first approach at trying to translate from that kind of point cloud that is really a big mess into something that actually captures all three elements. And if we zoom in again to the map that Kalev showed us, we can really start seeing some spatial detail, which makes it very interesting. And in summary, since Tim's giving me the cutoff because we're running behind symbol, so this, again, I want to really emphasize that this is just the first step. So this is by no means the only method, and this probably might not even be the best method. But what's really important for this is it started the dialogue. So through these maps, we've started this collaboration, and it's been really interesting emails and face-to-face conversations of, why is it highlighted here? Why is it not highlighted here? I really didn't anticipate that. What does this mean? And that's really interesting. And it actually, in terms of the project itself, raises a few interesting points. So we have to balance both managing the complexity of cyber infrastructure access. We want to keep it a black box as best as we can, but we also want to simplify the workflow. So we want to be able to do these things, these spatial analysis things, on this cyber infrastructure. But we also have to make sure that the user, Kalev or anybody else using this, can make sense of what's going on. So these are kind of a balancing act that we have to play in order to understand what parameters do you expose, how do you make this simple, with still being able to make sure that everybody understands what's going on. So before Tim cuts me off, so this is definitely kind of the beginning, and one of the most interesting aspects for me at least is what we're trying to do is translating spatial knowledge, kind of the experts that we are with how we look at space, to domain knowledge, to something that a domain scientist can use, such as a social scientist can use. And really that ends up answering a very basic question. Why is this here and not there? Why is this highlighted? Why is this not highlighted? And then we have to go back to the data, and really what we're trying to work on is sharing that through a map eventually within CyberGIS. And of course we have spatial aggregation issues. This is something that social media people have to deal with. Our social people have to deal with is representing locations as areas, not points, and that's something that we're trying to work on, which we'll have to change the methods. And with that, before I say thank you, I want to acknowledge a couple of collaborators, or a couple of people in our lab, Wolfgang and Anand in particular, and National Science Foundation, for providing the funding for the project, and of course the cycles in order to do the computation. And with that, I can say thank you.
Outstanding.
Lynn. Oh, you have to wait for the mic. Okay.
My question is, so what?
So what?
The map you showed, what does it tell us?
I'm gonna defer to the domain scientist.
So the idea behind this is how to...
We're streaming.
Oops.
Yep. Thank you.
Oh, sorry. So the idea behind this is what we really want to move to is being able to visualize the latent dimensions of text. What we're beginning to understand now, there's a rich literature that's beginning to emerge, say in economics. If we want to forecast things, for example, in economics, they found that, well, using using IBM's stock price gives us tomorrow's stock price decently well. But if we look at tone, we look at emotion, we can actually achieve many, many orders of magnitude better forecasts than the market. And this is happening all over the place. IARPA now, DARPA, basically any group that deals with trying to predict future human behavior is moving to begin looking at latent dimensions, whether that's emotion, whether that's different themes, whether that's just how things are being discussed. There's a huge movement towards this. The problem is that we're looking at that strictly in time right now. We're saying, for example, there was a paper using Twitter to predict the stock market last year, and it's just literally look through time. If you see a drop, the stock market's moving tomorrow. The problem is that obviously in the case of a single stock or something like that, time may be enough. But when we try to translate that to the human world, obviously there's not one society. It's not that the whole world moves. There's a conflict in Syria right now, but obviously we don't have tanks moving here in Urbana. And so space is absolutely crucial to try and understand that. So really what this work is really moving towards is trying to say, we're trying to understand latent information, but we need to be able to place that onto a spatial strata to be able to begin understanding it as humans, and also beginning to trying to use it in models, to begin forecasting. So I could say there's a relative risk of increased riots in the city someday, but not this city over here. And this is sort of the first stage, so we can actually at least begin to see this as human analysts, to begin understanding what this data is telling us.
One more quick question, James.
Yeah. Can you just go back to the map that you've got? The slide
how do I go back?
30, I think you can just click on it in the.
This map.
Yeah.
Yeah?
I guess.
I'm a Linux guy, not a Windows guy. All right.
There we go.
Come on.
There we go. We'll just show it right here. Yes.
Shift F5. Okay.
I guess what's interesting about that, what worries me about that is it doesn't necessarily reflect the population distribution of the UK very well. And so where you get the mention of places or I guess submitted Wikipedia articles, I just think it looks a bit odd.
So the idea.
And so one other thing, and I guess my other concern is that if you've geolocated things, say London, you're going to get, I don't know, 10,000 centroids on London. Mm-hmm. So if you did like a kernel density estimate on those 10,000 centroids, you're going to, the influence of London will spread out quite a lot. And I'm not sure if that you have any confidence, I suppose, about that.
Yeah, and actually in this case we actually want that. So for example, we want London to have a stronger impact here because there's more population there. So for example, if say armed conflict is a big discussion point in London, that matters a lot more to us than if it's a big discussion here in Urbana, Illinois. We want to emphasize that this is the first stage of this work. So for example, overlaying some of the work that I'm actually doing with Chuck and some of the Searle people in the back is actually basically providing this underlying data so that, for example, it can be overlaid onto human geography, so things like population and all kinds of other types of data. So basically the idea is sort of this first step of being able to at least see these so we can even ask these questions. Because, as we begin looking at many of these maps, we're seeing a lot of questions like this that, without these types of approaches, all we can do is say, well, I bet there's more discussion on London in this, but I don't know. So the idea is to really begin to sort of begin these first steps into this. So thank you very much.